Okay, good afternoon, everybody. So you can either follow along in the lecture slides for this particular lecture, or you can just look in the bash command notebook. The content is almost the same, regardless of which one you look at. So I'm just going to use the slides for now. These commands that I've been typing into the terminal, they can be one of 4 different things in bash. Either the command is something that bash understands on its own, so it's a built-in command, and we talked a little bit about those in the previous lecture. It can be an executable program, so that is, you could write your program in perhaps some other language, so C or Java or Python, and then you can save it somewhere on your system. If the location of the program happens to be known to the shell, then you can run that program from the shell directly. Right? And so for example, the ls program is a program that's written in C that's been compiled and is runnable for your system, and so that's a command that's available to bash. Right? So your bash, your shell can also run programs. There are these things called aliases. So an alias is basically a shortcut that the user has created that does some task. Typically, it runs some program with some command line options and some inputs. And rather than typing in this long sequence of options and inputs, you can make a little shortcut. I don't actually show you how to do this in the course, but if you want to, just look up bash alias, and you'll see that it's actually quite easy to do. I can show you an example of an alias in action. So I'm in sys 124. I don't want to be there. Okay, so we know ls. We've seen that command already, right? It lists the contents of a directory, right? If I type in ll, right, so 2 L's, I also list the contents of the directory, but it lists in a different format. And so this produces what's called the long listing of the, it produces a long listing. And so it lists the contents of the current directory, and now it gives you more details about the stuff that's in the directory. Right? And so when you type in ll, you see that, yes, there's a readme.md, it's right there. Right? There's an a.text, there's an apt.text, and so on and so on and so forth. Right? But now you see extra information. So for example, you see that readme.md, it was last, I think this is modified. I think it's the modification time. This was last modified on January 6th at 2 p.m. in the afternoon. This number here is a number that is related to the size of the file on disk. So it's 513 units. These 2 things here are, so they both say Burton. So this turns out to be what's called the owner, so that's me. And this is what's called the group, which also happens to be me. And over here, we'll talk about these more in detail in a few lectures. These are called the permissions that are set on the file. So this produces, oh, you also see that there's dot and there's dot dot, right? So when you type in ll, you get information about the current directory, that's dot. You get information about the parent directory, which is dot dot. You'll also notice that there's this other file here, .ipynb underscore checkpoints. And so in the way this works in Unix is that, or in most shells anyway, in most Unix shells, is that any file that starts with a dot is considered, usually your shell considers that to be a hidden file. So in other words, it's a file that's not normally displayed unless you ask it to be displayed explicitly. Right? So notice when I used ls, right, those files aren't displayed, right? So dot, 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 and dot .ipynb checkpoints, not displayed, because they're by default hidden. ll, the long listing, shows the hidden files. Right? So if you have hidden files in your directory and you want to see what's there, you need to ask for the long listing of the directory contents. All right, so is ll actually a command? So it turns out no, it's not. Instead, it's what's called an alias. And so here, right, you'll see that ll is actually short for the command ls minus alf. Right? And so I'll explain more about the ls command a little bit later in this lecture. But it's an alias. It's not an actual command on its own. Right? It's simply the name that Ubuntu has decided will correspond to running the ls command with those inputs there. Notice that ls on my computer is also an alias, right? So ls is also aliased. It's aliased to the ls command, and it asks the ls command to use colors to convey some information to the user. Okay, so those are aliases, and finally there are these things called shell functions. So shell functions are just functions. So in bash you would write the shell function in bash. And so it's a function that you can store somewhere, and it turns out that in bash functions can be called just like they were commands. And so perhaps we'll look at a little, we do write functions in bash. Whether or not we use them in this form is another story. But that's not until week 4 or 5 of the course. Okay, if you want to know what kind of command something is, you can use the type command. So type is a built-in command that will give you information about another command. So for example, if you type in type ls, so I'm not sure if this tells you it's, okay, so this one says it's an alias. If I type in ls, type, this should say it's, yes, okay, so that, so that just says bin ls is in fact bin ls, which is great, right? And type pwd should say it's a built-in, right? So this bin ls is telling you that the program bin ls is in fact a command and not a built-in, sorry, it's not a built-in command, it's an actual program on your machine. Okay, if you want to know where the command resides on your computer, you can use which. So which ls? Okay, so this one happens to be smart enough to not tell you information about the alias. It actually tells you information about the command itself, right? And it says it's in user bin ls. Right? You might wonder, hey, didn't you just say it's in bin ls? In fact, it is also in bin ls. Right? So if you actually list the contents of the directory bin ls, in fact, you will find the command ls. And so what's going on in Linux is that, root, there's a directory bin. There's also a directory usr, so user. Right? If you look in the user directory, you will find another bin directory. And if you go into that bin directory, you will find all of the commands that appear to be in root bin ls. Right? So if I go back to root bin, that appear to be in root bin. Right? And so they appear to be the same thing. What's actually going on here is the following. Right? Let me do the long listing for this. There we go. So bin, this directory that appears to be named bin, is in fact what's called a soft link to the directory user bin. So a soft link, so remember a hard link is, maps a file name to an inode. A soft link maps a name to another name. So it maps a file name to a file name. And so here, bin happens to map to the directory user bin. Right? And so they are in fact the same thing. They're both the same directory. It's just that bin is now a short form for user bin. So we call that a soft link. On my computer, it shows soft links in green. If you ask for the long listing, it'll show it to you as an arrow. You can see that lib is also a soft link to user lib. Right? lib64 is a soft link to root user lib64. All right, so ls. So I should tell you a little bit about this command and exactly what it does. And on assignment 1, which should come out either on the weekend or early next week, we'll have you using all these basic commands. All right, so ls on its own lists information about the current directory. Right? So it lists the files that are in the current directory, right? And we've seen lots of examples of that already. So let me switch back to my home directory. Right, so I type in ls, it lists the files in the directory, the non-hidden files and directories that are in the current directory. Oh, if you want to, you can ask for information about specific files, right? And the files can be directories or they can be files. So let me just show you some examples here. All right, so there's ls. No input arguments, lists the contents of the current directory. Suppose I would like to know what's in 2025 winter. Right? So if I ask for information about a directory, right, it lists the files that are in that directory. Right? And it says there's two directories, sys124 and sys220. Notice what it doesn't do. It doesn't list the information that are in the directories of the directories and so on and so on. Right? So when I ask for what's in 2025 winter, it tells me there's two directories. But it doesn't tell you what's in those directories. Right? If you want to know what's in those directories, you have to specifically ask for them. So for example, sys220, and there you go. Right? And notice there's two more directories and so on and so on and so forth. Right? So ls, you give it a directory name, it lists the files that are in that directory. ls on its own lists the information in the current directory. Right? Don't forget that dot is the name of the current directory. So I can do ls dot and that produces the same result. Okay, so I have a file, sys222 notes.zip, right? That is in this directory. So I can ask for information about a file, right? And so if you ask for information about a file, it doesn't seem very useful. It says, yes, the file is there, right? I already know the file is there, so that doesn't seem very useful, right? So if you use ls and specify a file name, it gives you information about that particular file. Now, if you're asking for information about a file, you probably want to know something specific about the file, not just does it exist, right? So for example, you might want to know how big is the file. And so that's what the options are for. So ls minus s, short for size, right? That says that sys220 notes.zip is 9,004 units big, whatever a unit happens to be on my computer. Right? Okay, so when you use minus s, at least on my system, it tells you the size of the file in what are called blocks. And so I think a block on my computer is 1,024 bytes, I believe. Bytes? Megabytes? I can't remember. Kilobytes, probably kilobytes. So probably 1,024 bytes, right? Okay, so this file is actually roughly 9 megabytes big. Now, you probably want something that's easier to read than blocks, right? Because that's used in blocks. So there's an H option, right? H is short for human readable. And so that tells you, oh, this is actually 8.8 megabytes big. Right? And so you can combine options, right? You have multiple options at the same time. Usually, you don't have to list the options separately. So most commands will let you combine options. So ls minus sh does the same thing as ls minus s minus h. Right? And then finally, many options appear have both a short form, so single letter, and a long form. So for example, ls minus s minus minus human readable, like that. Right? And so that does the same thing. So minus h actually has a long option as well. Or in other words, minus h is short for minus human readable. And all of this stuff is in the lecture. Right. Okay, so there's using minus s, using minus s. Right. There's using minus sh. Right. And so in general, when you use a command in Linux, in Bash, and in most shells for that matter, the way it works is you type in the name of the command. Right. If you have any options, the short form options anyway, start with a single hyphen. Right? Some options have arguments. So you'll run across commands where you use an option, but you also must pass in extra information when you use the option. And we'll see examples of those later on. Right? And then you can pass additional arguments to the command. Right? So both the command can have arguments and the options themselves can have arguments. Right? So the options are also called flags, and they modify the behavior of the command. The arguments, if you need more than one argument, typically most commands expect the individual arguments to be separated with a space character. Right? So one or more space characters. All right, so here's another example of using ls. So minus capital A, sh, and 1. So let's see what that does. ASH1. Let's just do that. Okay, so the minus A is is short for almost all. So this will list all of the hidden files except for dot and dot dot. Right, so notice dot, dot, and dot are not here, but all of my hidden files are. Right? So notice that in my home directory, there's lots of hidden files. So typically, the hidden files are used to store configuration information. So for example, .bashrc that's the file that that bash reads when it first starts up. So whatever options I have set for bash, they probably live in that file there or a similar file. Notice that there's a bunch of directories here. So there's a .Jupyter directory, right? So that's where Jupyter is storing information about the program state. Local is where some software is installed under my account. What else is here? Oh, there's no SSH. OK, so I haven't set that up yet. And there's a bunch of other files as well. .vim info, this is where one of the text editors that I use stores information about the state of about that program there. So that's the -a, so almost all. S is size, H human readable. 1 means in one column. Right? So it produces one column of output. Lists information about each file, 1 line or more per file. Right? You might wonder. Good thing I checked that. I just turned that off. OK, so one of the weird things in Unix is that Unix doesn't. There's only one rule about what character can appear in a file name. And the only rule is you can't put a slash in a file name. Right? So remember, the slash is the name of root, and it's also the directory separator. So Unix doesn't let you put a slash in a file name. You can use whatever character you want otherwise, though, in a file name. And that includes the new line. Right? So you can have it's possible to have a file name that spans multiple lines of output. I don't recommend you do that. It makes tools like ls very confusing to use. So for example, someone here, most people will expect ls to list 1 file per line. But if you have a file name that has a new line character in it, it's going to take 2 lines of output. If you have multiple new lines, it's going to take multiple lines of output. And that will be really confusing for many other users on your system. So you're allowed to put in special characters in a file name. The generally given advice is you should probably avoid special characters in a file name. So let's see what happens if I don't put the 1 in. Right? So if you don't put the 1 in, you still get the size, and you still get the hidden files, but you don't. The output is now the number of columns you get depends on how ls decides to generate its output. Right? Here it's decided to generate 1, 2, 3, 4, 5 columns of output. Right? But on your computer, it might generate less. On someone else's computer, it might generate more. Right. There is a difference between the little a and the capital A. So the little a as an option means everything. So it means all. So if you use the little a, that's when you get dot and dot dot as part of your output. Right? So that lists all of the hidden files, including dot and dot dot. So that's the difference between little a and capital A. There are your long form options. So capital A is minus minus almost all, right? Minus H is the same as minus minus human readable, and minus S is the same as minus minus size. OK, so there are some commonly used options to ls. So the A's are commonly used because it's often the case where you need to see your hidden files, so you need to ask for them specifically. If you use minus D, I'll show you what that does in just a second. So that lists the directory names instead of the directory contents. So I'll explain that in just a second. Minus F appends an additional character to indicate the file type. It's not super useful, to be honest. Minus H is human readable. Minus L, so that if you ask for the size, it gives you the size in some sort of human readable format rather than blocks. Minus L is for your long format. You can reverse the order that it shows you things in. So by default, it uses alphabetic ordering. You can reverse that if you want to, and if you can also do things like sort by size and so on and so on and so forth. Right? So you can see here minus T sorts by the time at which it was last changed. Right? You can reverse the order of those operations as well. Right? And there's actually many other options to ls. So these are only some of the commonly used ones. What happens when you specify a directory? So you might wonder, why is there a minus D option? OK, so remember what happens if I type in ls on its own, it gives you information about the current directory. Right? If I specify a file name, it gives you information about the file name. if I specify a directory, normally what it does is it tells you what is in that particular directory. Right? Sometimes you don't want to know what's in the current, you don't want to know what's in the directory. You simply want to know that the directory is there. Right? And so if that's the case, you can use the -d option. So with the -d option, if the thing that you're asking information about is a directory name, then it only prints the directory name. It does not print the contents of the directory. Right? And so that's what the -d option does. I might as well show you this now. So I'm going to talk more about this in detail later. But the shell has what are called wildcards. And so the star wildcard, when you use it, when you use the star in the way that I just used it here, the star matches any sequence of characters. So when you use it in the way that I'm showing you here, the star will match the file name of anything that's in the current directory. Right? So star means, in this context, right, it means it matches the 2025W, and it matches the file name sys220notes.zip. Right? So the star, when you type this in, we say it expands to everything that it matches. Right? So in other words, when I type this in, when I press enter, the shell will take the star, right? It'll determine what does the star match, and it will replace what the star matches with the star. It replaces the star with what it matches, right? So when I type in ls star, I get the following output, right? So I get, it's as if I had typed in ls sys220notes.zip followed by 2025 winter. Right? So I can pass in multiple arguments to ls, and ls will print information for each of those. Right? So that's a file, so it prints out the file name. Right? That's a directory, so it prints out the contents of the directory. Right? You can achieve the exact same effect in this case by typing in ls star. Right? So I don't have to type in both directory or all of the file and directory names at once. Right? If I want information about everything, I can just type in ls star. Right? The star expands to match everything in the directory. Right? Okay, so it could very well be the case that when I list the contents of the directories, I don't care to know what's in the directories that are in the directory. Right? I just want to know what is the name of the directory. Right? And so that's what the -d option is for. Right? When I type in ls -d star, right, that's the same as typing in ls -d sys220notes.zip and 2025 winter. Right? Again, right, when you ask ls for information about a file, it prints out the information about the file. Right? By default, when you ask for information about a directory, it lists the contents of the directory. The -d changes the way that ls works when there's a directory name. Right? If there's a directory name, it only prints out the name of the directory. Right? And so you get that. Right? And so when you're working with these wildcards, right, and the wildcards are matching both directory names and file names, it's often the case that you don't want information about what's inside the directories that get listed. Right? You only want the names of the directories. And so that's what the -d option is for. Right? Any questions so far? All right. ls is so ls is not a built-in command, but it does accept the help option. So if you type in ls-help, you can in fact get some documentation about the command. Right? Alternatively, ls is not a built-in command, so you can do man ls, and it will also give you information. So this gives you the man page for ls. And I guess it's useful to show you how to read one of these things at this point in time, in case you decide that you want to use a man page instead of looking stuff up on the internet. So let's look at man ls. All right, so what happens when you run the man program is it goes and finds the manual for ls, or the command that you ask for, and then it displays it to you on the screen. A lot of these manuals are very long, so they don't fit in on one screen. And so what man does is it actually sends the output of the manual. So it prints the manual out to the screen, but it redirects that output to another program called less. And less is a program that lets you see information one page at a time. So down here, you can see there's a press H for help. So less is complicated enough to use that you actually need help to use, many people need help to use the program itself. So if you press H, you'll see this. Right? And so it says, here's the summary of less commands. Right? So for example, if I want to move forward one line at a time, I can use one of these characters here. Right? E. If I want to move backwards one line, I can use Y. Right? Typically, you're going to move forwards one window or backwards one window at a time. So those are easy. It's F and B. Right? F, move forward one window at a time. B, move backwards one window at a time. Right? And so on and so on and so on and so forth. Right? There's more help here available to you if you want it. When you type in man, one of the problems with the man pages is they have no standard formatting. There is a recommended format, but if you are a command creator and you generate the man page for you write the man page for your command, you might choose to use some other format. Most of the GNU utilities follow the same format. But if you find someone else's program on the internet, they may not have a man page for their stuff, or it might be formatted in a different way. You have to get used to looking at man pages in various, that have various different formatting. For most of the commands that we use, it looks like this. So at the top is the name and a very short synopsis of what the thing does. Right? So ls lists the directory contents. Right? The synopsis tells you very briefly how do you use this thing. Right? So you type in ls. Right? Anything in square brackets is optional. Right? ... means 0 or more. So this says there are 0 or more options, followed by 0 or more file names. Right? And the description now tells you a little bit more about what it does. It lists information about the files. Right? And it says if you don't specify a file, you get information about the current directory by default. Sorts entries alphabetically if none of all of these things, all of those options are specified. Right? And then it gives you very, very brief information about all of the options. Right? So -A is short for -all. Right? Do not ignore entries starting with dot, so show all of the hidden files. Right? -A, same as A, but don't show dot and dot dot. Right? And then so on and so on and so on and so forth. So if I want to see the next page of information, I type F or space. Right? And you jump forward one page. Notice there's lots of options. Right? And this is one of the problems with commands in Bash, or Unix, sorry. Right? Most of the commands have many options. Does anybody use all the options? Probably not. Does anybody remember what all the options are? Definitely not. Right? Unless they have a photographic memory or something like that, which I do not. So I couldn't tell you even 1/4 of the options that ls has. Right? And there's lots of them, right? Boom. And you can see there's many, many pages of options. So do you have to memorize all this stuff? No, of course not. Right? No one's going to expect you to memorize all this stuff for this course. Well, I'm not going to ask you to memorize it anyway. Okay, so that's very briefly how you can use a man page. To be blunt, it's probably easier in this day and age to simply look stuff up on the internet. But remember that back in the day, we didn't have that luxury. So back in the day, all you had was a terminal. And so that's why the man pages exist. That's one of the reasons the man pages exist. Also notice that the man pages are intended as a reference, not a tutorial. Right? And so if there's some command that you've never used before, looking at the man page often doesn't help, especially if you're new to Bash. Right? So often it is easier simply to look stuff up on the internet. Okay, so if you want to, you can look at the, I guess this is worth doing very quickly. So remember the calsay program? It uses a cow to print out something. Right? It has a man page, so you can look at it. And this is an example of a man page that is not formatted in the standard way. Right? So notice it looks very different than the one I just showed you. And in fact, if you actually try to read this, it's very hard to read. So there is a way to draw it with a different animal. The problem is you have to read all of this text to figure it out. I'm not going to do it. It's in here if you want to know how to do it. It is possible to draw, oh, there's some examples here. Oh, that changes the way the cow looks. So there is a way to change the way the animal looks like. But you have to read through all of this, which is annoying. Right? So for example, I just discovered that if I use the -L switch or option, I can actually find out what animals I can use for cowsay. So cowsay -L, right? And there you go. So it looks like you can use a bunny or Calvin from Calvin and Hobbes, or cheese. I've never seen cheese before. A demon. There's Hello Kitty here somewhere. Yes, Hello Kitty, and so on and so on and so forth. Right. So cowsay -F. Hello Kitty. Hello. Voila. It uses Hello Kitty instead of a cow instead. Right. So there's an example of a man page that is not formatted in the standard way. I actually don't know what happens if you Google cowsay to see if there's any help for it. I've never tried to do it. Okay, when you're working at the terminal, what you're going to find, so you're typing stuff into the terminal, right? That's how you interact with the operating system. So you'll often find yourself in a situation where you do some complicated task. So you run some command, it has lots of options, has lots of inputs, right? And then later on you decide, hey, I want to run that command again. This time I want to change one of the inputs or something like that. So for example, when I generate your assignments, I use a program called Pandoc from the command line to generate the web page for the assignment. And it's to use the command, I have to specify a lot of stuff. And so I don't want to type in the command over and over again. Bash has a handy feature. It has a history. So it remembers the commands that you've typed in the past. And so this is nice when you're working on the command line. So using the up and down arrows on your keyboard, you can look at the previous commands. Right? So if I press the up arrow, it goes back, it shows you the previous command. Right? So the last command that I ran was cowsay -F hello kitty hello. And if I press the up arrow again, it goes to the command before that. And so on and so on and so on and so on. Right? So you can go backwards, sorry. If you press the down arrow, you go forward in the history. So the command that I ran after PWD was CD 2025 blah 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 blah. Right? And so on and so on and so on and so on and so on. Right? So up and down arrows are handy, especially if you're typing in commands that you want to repeat over and over and over again. You don't have to type them in over and over and over again. You can just use the up and down arrows and go figure out and go look at the command. You can also then edit the command. So for example, here's the previous command that I ran. If I wanted to use something else, I can now go in and edit the command and use something else. Oh, I guess there is no daemon. Calvin? No, sorry, can't type. Calvin. There's Calvin saying hello. Right. So now you can go in and edit the previous command that you typed as well. So that's nice. If the command that you ran was some time ago, then you might want to just list all of the commands that you have previously run. So that's the command history. So history will list, I don't remember how many commands. Is it 100? Okay, so there are I guess the last, well, I haven't typed in 100 commands into this bash session, so I guess I don't have 100. But here are all the commands that I ran before. Right? Each command has a number beside it. Right? So number 1. And here's, so you can see here, this is how I installed all the course software, if you haven't done so already. So let's suppose I wanted to go back and run command number 45. Right? So instead of typing all that in, I can type in ! 45, and it will rerun the 45th command, right? And so now I'm in now I'm in the notes directory. So the history is handy to have. It's often useful to use the history if you're doing a lot of work on the command line. Tab completion is also handy. And so tab completion will try to finish file names and command names for you. So the way it works is you start to type in a command. Right? So you type in the first few letters of the command and press tab. If those first few letters of that command are unique, right? So in other words, there's no other command with those first few starting letters, tab completion will automatically complete the command. It also works with file names. So for example, cowsay. So I can type in cow, and I can press tab. Right? If you press it a second time, it will show you all of the commands that start with cow. So cowsay and cowthink. I think they're the same thing, except they draw the bubble differently. Doesn't matter, right? So cow s and then tab automatically completes to cow say. Right? I'm in the directory here. I've got some files here. Okay, so I've got one file that starts with the big R, right? So if I wanted to see what's in that file, I can use the cat command, right? And now I need to say which file I want to look at, so I can type in big R. I don't have to type in readme.md. I can just type big R, then tab, right? Tab completion automatically completes the file name for you. Then you can press enter, right? So one more time, I want to look at. Well, let's see. So we have two files with a name that start with an A. So if I type cat A and then tab, nothing happens because it can't automatically complete, right? It doesn't know if you mean a.text or apt.text, right? Type in a second letter, and now it can automatically complete it because there's only one file that starts with AP, right? And you get that there. So tab completion, also super useful when you're working on the command line. Yeah, that's fine. Oh, all right, I guess I should show you this. Okay, so in Unix, there's no requirement that your commands have unique names, right? So you can have 2 commands or 100 commands called ls on your system, right? This turns out to be a not uncommon problem. When you're looking for help for one of these commands using a man page, the man pages are organized into what are called sections. So you may have to specify the section for a particular command. Now, for our purposes, again, most of you are probably going to use the internet, right, to look for help. Whoops, sorry, where'd it go? There's a here. The only man page that I'm aware of that you might want to look at, where you can't just type in man blah, is with when you want to know information about the wildcards, right? And so the wildcards are called globs in Unix, and so if you do man glob, you don't get the right thing, or you don't get the thing you probably want, man glob, right? So if you type in man glob, what you end up with is the documentation for this function called glob, right? Which is probably not what you want. 7 glob. Right? So what I actually want information about is how do these wildcard patterns work? And so that's where an example of where you have to type in the section name. How do you know the section name exists? Well, you don't. So it's kind of hard to use, right? So in this case, I had to look up what section the actual man page was that I wanted. But that's an issue that that man has to deal with, right? Okay. So more about these globbing patterns. So all of the work that you're doing involves files. And often you want to work with multiple files at a time, right? Or you are in a directory somewhere and there's lots of files in the directory and you want some specific subset of those files. And so the wildcard patterns let you specify patterns of file names. So the star I already showed you, right? The star on its own matches any number of characters, right? Including 0, so it'll match no characters as well. On its own, it matches all of the file names in your current directory. However, if you use it as part of a file name, then it matches any number of characters where the star appears, right? So I'll show you an example. Let's look at an example of that. So I need to find a directory that actually has a bunch of stuff in it. So bash. Sure, let's look at this. Okay, so here I've got a bunch of files. These are the notebook files, by the way. So suppose I would like to list all of the files that start with an F, right? So what I can do is I can write lsf and then star, right? Remember what happens with the star? The star matches any sequence of characters, right? So this defines a glob pattern that is F followed by anything, right? And it'll match all of the things that begin with F. Right? And so when I do that, I get 1, 2, 3, 4, 5 files, right? So all of the files that begin with F. One more time. So when you do this, this is what's actually called, this is an example of what Bash calls an expansion. So when you type in lsf star and press enter, one of the things that happens is bash sees the f star, and it now replaces the star with its expansion. Right? So the star matches any sequence of characters. Right? So it replaces the star with, so it does lsf, right? And then ILENAM, blah, 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 IPYNB. Right? And then it replaces, and then it does it again. So now it does F ILES IPYNB. And then it does it again. So IL system, right? So in other words, when you write in LSF star, it's exactly as if you had written S file name expansion. So here I'm using tab completion to make my life a little easier. Right? File system, fruits, and functions, like that. Right? So that, as far as bash is concerned, is the exact same as if you had written in all of this. Right? And obviously, writing in all of this is tedious and time-consuming. Right? And so the wildcards let you do operations like this in a simple way. Right? If you wanted to see what's in all of these files all at once, you could do the same thing. So cat f star. Cat f star, like that. Right? Concatenates all of the files together and then spits the contents out to standard output. And you can see there's a lot of stuff in these notebooks. So cat f star is exactly behaves exactly as if I had written cat file name files file system fruits and then functions, right? So so again the use of a wildcard to process multiple files all at the same time. Okay, so what else is here? So suppose I wanted just the files that end with .ipynb, ls star ipynb, right? So match anything followed by .ipynb, right? And so that shows you all of these are all of the notebook files. So if you wanted to list all of the, say, JPEG files you have in a directory, you could type in lsstar.jpg. Right? Okay, ls. So suppose I want stuff that starts with file, has an S in it, files followed by anything, followed by an S, followed by anything, like that. Right? So you can use the wildcard character more than once in a name. Right? And so that says, well, you have the file, that matches the file names, file name expansion, files, and file system.ipynb. Okay, the question mark, do I have time for this? Yes. The question mark matches any single character. Right? So it has to be a single character, right? So the star also matches no character, which I guess I should show you. So ls star ipynb star. Right? So that matches all file names that have the substring ipynb in it. Right? So notice these end with ipynb, so the star also matches the no character. Right? The question mark matches a single character, right? And there is no such thing as the empty character, so it matches any single character. So for example, if I wanted to, probably not a good example in this particular directory. We can do lst question mark dot star. Okay. So what does this match? So this matches any file name that starts with a T, right? Followed by one character, followed by a dot, followed by anything. Right? And so that's going to match tr.ipynb. If you wanted to know what are all of the, is there a good example here? 1, 2, 3. Right, so that'll list all of the entries whose file name is 3 characters long, followed by .ipynb. Right, of which I think, oh, there isn't any. Okay, so there aren't any, so now you get an error. Is there one that's, well, the tr is 2, so I can do 2. So that matches any 2-character file name that's followed by .ipynb. So they're right there. More example? Yes, there are. Okay, if you use the square brackets, that matches any single character inside the set of square brackets. Right? And if you want to not match a particular character, you can use the exclamation mark instead. Right? So square brackets, exclamation mark, characters. So it matches any character not in the set characters. Right? And then there are these things called character classes, which I'll get to in just a second. So here's a bunch of examples. Right? So star on its own matches all files, except the hidden files, unless you've configured your shell to show you the hidden files. Right? So it's possible to configure bash to always show the hidden files if you want to. A star matches all file names that start with A. Right? Star.txt matches all file names that end in .txt. Right? A star.txt, all file names that start with an A end in .txt. Right? So X question mark Z, any 3-character file name that starts with X, ends with Z, any character in between, but there has to be a character there. Right? So for example, that will not match X, Z. Okay, so here are the character classes in this example right here. Right? So X and then square brackets, and then inside the square brackets there's Y, Y, 1 and 2, and then it's followed by a Z. So that matches the names X, Y, Z, right? So it'll match the Y in the middle, right? X capital Y, Z, so it'll also match the Y, the capital Y in the middle, X1Z or X2Z, right? The square brackets only match a single character inside of them. Right? You are allowed to specify ranges of characters, and this is often useful, right? And so X square brackets, A hyphen Z matches any 3-letter file name, starts with X, ends with Z, has a lowercase letter in the middle as the middle character. Right? This is often useful, especially when I'm processing your OnQ and your assignments from OnQ. So the way that OnQ works is that it, when I download your assignment, it spits everything back out, and all of your files start with your name. So it always starts with a capital letter. So if I want, and I typically have a bunch of other files in the directory when I'm marking stuff. So I have a bunch of other files that start with a lowercase letter. So if I want to know what students submitted their work, I can type in ls big A big Z star like that. Right? So that matches all file names that start with an uppercase English letter, of which there are none in here. So that's, this turns out to be more useful than you think it might be. 0 through 9 are the digits 0 through 9, right? So this will match X0Z, X1Z, up to X9Z, right? And if you've got a bunch of files in your directory and they're named as, it's some number of digits followed by an extension, well, those are easy to match, right? So if you have a bunch of PDF files, so imagine you have a PDF document and you split it up into individual pages, right? It's not uncommon to save the pages as 01.pdf, 02.pdf, and so on and so on and so forth, right? If you want to list all those files, square bracket 0 through 9, square bracket 0 through 9.pdf, and that'll do it for you. Okay, there are these things called character classes. You have to be a little bit careful when you use them. And so these are called the POSIX character classes. So these are the character classes that POSIX has mandated every Unix system should support. And I don't have a Kleenex. Okay, so if you want to match all alphanumeric characters, you can use square bracket colon alnum. Right? So that'll match any letter, any English letter, or any digit. Right? If you just want the alphabetic characters, so any English letter, square bracket colon alpha. If you want the numbers 0 through 9, you can use square bracket colon digit colon square bracket. Right? The lowercase letters are lower and the uppercase letters are upper. Now the weird thing about the character classes is when you use them, you need to put them inside of square brackets a second time. Right? So for example, if I want all the files that start with an uppercase letter, I can write square bracket and closing square bracket, then inside the name of the character class. Right? So square bracket colon upper colon square bracket, and then the star. So that matches all files starting with the letters A through Z, capital A through Z. Right? If I want to ignore all the files that start with a capital letter, I negate the character class. Right? So square brackets and then the exclamation mark, right? And then the name of the character class, right? So those are all files not starting with A through Z, right? If I want the files that start with an X and then end with one, followed by one digit, X square bracket digit inside. Right? And so you can also use the POSIX character. There are more of these than just the ones that are listed here. You can also use the POSIX character classes as when you use a wildcard. All right, any questions about today's lecture? All the information is also in the command notebook, I believe. Is in the notebook's command. And file name expansion covers the wildcards. Right? And I'll probably have more to say about that tomorrow because it turns out to be a pretty fundamental task that in Bash.